Hey, this is Mr. Hansen. I wanted to look at something with you. It's called the Pythagorean identity. And the question here is, could I find the ratio of sine of an angle if I'm given the ratio of the cosine of that angle? So let's go over what that means. If I had sine is opposite over hypotenuse, if I had opposite over hypotenuse, could I determine cosine adjacent over hypotenuse? So that's kind of the question there. And we're going to use the Pythagorean theorem to help us solve that. So you might remember the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So I'm just going to write opposite squared plus adjacent squared equals hypotenuse squared. And you might remember that one property of algebra is that you can divide both sides of an equation by the same thing and you still have an equation, a balance there. So I'm going to divide everything by the hypotenuse squared. Hypotenuse squared, hypotenuse squared, and hypotenuse squared. And over on the right side of the equation, we can see that that just equals 1. And, well, the opposite squared over the hypotenuse squared is going to be sine squared, because opposite over hypotenuse is sine. Sine squared theta plus adjacent over hypotenuse is going to be cosine squared theta. So here we have a formula that will help us determine, could I find the ratio of sine? It'll help us to determine sine if we had cosine. So this is kind of the formula, the part that you memorize, hopefully understand where that came from. So I'm going to rewrite the formula now. Sine squared theta plus, I know my ratio for cosine might be 0.707 squared equals 1. Okay, so I just picked that number there, 0.707. And let's go ahead and square 0.707. So we got sine squared theta plus 0.707 squared is 0.4998 equals 1. And then let's get sine squared theta alone. So we're going to subtract the 0.4998. So sine squared theta now equals 1 minus 0.4998. It's 0.501. And we're almost there. We just need to square root both sides because we're squaring the sine function here. We're not squaring the angle measure, we're just squaring the sine function. So I'm going to square root this and square root that, and we get sine theta equals, it's 0.707. Okay, and so we just found what the ratio of sine was when the ratio of cosine was given to us. Now, I just want you to think about this particular triangle. If the ratio for sine and cosine are the same, if this over that equals this over that, then it's probably a 45-degree triangle, so 90, 45, 45. Just something to think about there. The big idea here is to remember this function, or this identity here, and if you have a value, a ratio for the sine of theta, you can plug it in and find the cosine of theta, or if you have a ratio for the sine of, or for the cosine of theta, you can plug that in and find the sine of theta. So that's kind of how that works. Thank you very much.